Okay, let's take a look at how to use a multimeter when we're measuring voltage, current, and resistance in our circuits. So in front of you we have a simple circuit hooked up to a breadboard where I have a 9-volt battery connected. I'm using the rails in order to bring power from my LED across through a switch, through a resistor, back to the battery. So I'm creating a simple series circuit there. And when I open up the switch, when I close the switch, I'm able to allow for current flow and turn on my LED. So one of the questions might be, what's my voltage? How much voltage do I have in this circuit? So what's the pressure in the circuit? So what I need to do is use a multimeter in order to check that. So I'm going to grab this multimeter here, and I want to set it for the appropriate amount of voltage setting. Now in a lot of different multimeters, you might have different ranges. This one's what they call an auto-ranging multimeter. So all I need to do is turn this to voltage with the straight line. This represents DC power, direct current. So voltage, this one would be AC. So since we're using a battery in order to power our circuit, this is the one that's going to be the correct range. I'm going to make sure that my leads are in the right location here. So the black one stays in common, and the red one's the one that I would move to different places. So since I'm measuring voltage, it stays in here. Notice what happens when I pull it out. It lights up red to let me know, hey, you need to plug it in over here. If I have it plugged into the wrong location, it blinks and says you need to switch and connect into here. Okay? Our units right now are reading in millivolts, and for us, millivolts is not really something we're worried about. We need a little bit more voltage than that to really get a reading, because just in the air, we're going to get a millivolt reading. So how do I measure voltage in a circuit? Well, I need to connect it into parallel. So what that means is, notice that the LED is on right now. What I'm going to do is connect my two leads on either side of my components in order to see what the voltage is. So for example, my 9-volt battery, I'm going to touch both the positive and negative side of the battery to get a voltage reading. And in this case, I'm getting 8.8. If I measure across my LED, I'm getting 4.73. And I can measure across my switch. So what I can do is touch the bottom wire here and this wire here. I should be getting next to nothing across the switch when it's closed. I'm going to measure across the resistor. So 4.06. Now you might have noticed something, that the voltage across the LED added to the voltage across the resistor gives us roughly the amount of voltage that's coming out of our energy source here. That is one of our Kirchhoff's rules for voltage. The voltage drops, the sum of the voltage drops equals our total voltage here. Alright, using this simple series circuit, we want to know how much current is flowing through the circuit. We know in a series circuit, no matter where we take our measurement, it's going to give us the same answer, because current is the same throughout a series circuit. So what I need to do on my multimeter is to change the range to the appropriate range. I'm not sure how much current is flowing in here, so I always want to start at my highest range and then work my way down. So here we have amps, milliamps, and microamps. So our amp is along the largest range. So notice when I do that, this starts blinking and says I need to move the red lead over to make it happy. Okay? Notice my units right now are amps. Whenever I hook up a multimeter in a circuit and I'm measuring current, it needs to be broken into the circuit. So I need to break the circuit, connect the leads so that it's what we call a series connection. Alright? So when I do that, I should notice that the LED is going to go out, and then when I touch my two leads to it, it's going to come back on. So let's say, for example, I pull my red wire. Notice the LED is not on. I can then pinch this wire, and then I can go ahead and I can slide this back in, and we can see that the LED went back on. And notice that my multimeter is barely reading anything. What that tells me is that the range that I have is too large, so I need to go down to a smaller range. So it's going to have me switch again to a different place, and then I'm going to go ahead and connect exactly the way I did before. I'm going to pinch the one lead, I'm going to slide the probe into the breadboard here. And now I'm getting a negative 38 milliamps. Now notice it's going to bounce around a little bit based off of how I'm connecting here. and it's negative because I connected the leads backwards. But it's not going to matter. This is smart enough to know that it's backwards. It just gives you a negative number. So again, we were right around negative 37 milliamps. Okay? So if I were to measure somewhere else, let's say at the resistor, what's the current flow through the resistor? I can pull the lead of the resistor out, so the circuit goes off. I'm going to touch the resistor with one of the leads, and I'm going to go ahead and touch the resistor or the switch with my other probe. Notice that I'm at right around the same amount, 38 milliamps. The LED is back on, and I'm positive because I connected it with the leads in the other direction. So it doesn't really matter if it's negative or positive. We're just treating it as if it's a positive value here. So now I want to use the multimeter in order to measure the amount of resistance that we're getting through components. What's really important here is that we can't have any power in the system. When we set this to our resistance or our ohm meter, what ends up happening is it has very, very, very low internal resistance. And if we put current flow through it, it can actually damage our multimeter. So first thing I want to do is I'm going to change my range to ohms. Now notice that my leads aren't connected. It's going to have me change my lead position over here again. And then I'm going to take the component and physically remove it from the circuit so that I can go ahead and I can measure how much resistance there is through this resistor. And in this case, it's getting approximately 330 ohms of resistance. That's good because according to my scale, I've got an orange-brown resistor, and that's right at 330 ohms. Now you might notice some other components when I grab them, say for example an LED, and I connect to see what the amount of resistance is. I'm getting a value up there that's right around 5 or 6 mega ohms. So it's extremely high amount of resistance. That has to deal with the connection here in an LED, which really isn't going to give us an accurate reading here. If I have my switch, what's the resistance for the switch? If I have my switch closed, I'm going to get not much. It should allow current flow pretty easily. If I open the switch and I do the same thing, I should get an extremely high number again because I made a connection. I broke the connection in here, and it's not allowing for current flow at all.